Lesson 10.1 Polygons. Let's quickly do the homework in the previous lesson given to you. Now guys, here I have drawn or given the table to you with all the answers in already, but I will just like to demonstrate one of them, and I have decided I'm going to do or demonstrate the Pentagon. Now first, in this one here, penta means 5. So therefore vertices, if I count it, I'm going to count 1. Now that's the corners. 2, 3, 4, 5. So I'm counting 5 vertices, 5 corners. Now I want to talk about the number of triangles. What do we mean by the number of triangles? And that's a nice one to understand. Now what I'm going to do now is, that means I have to draw triangles inside this polygon. So when I'm going to draw it, and now if I draw it from vertex to vertex, it means I'm going to refer to a diagonal. Now if I draw the diagonals, it means when I draw from vertex to vertex, they're not allowed the diagonals to intersect each other. So the next one, you can either draw it from this vertex to that one, or from that vertex to that one. I have decided to draw that diagonal vertex to vertex. So I'm not allowed to draw this one here, because then I'm going to intersect the two diagonals. And how many triangles inside this pentagon I do have now? I have 1, 2, 3, and that's where the number of triangles coming from inside the pentagon. And then if you add all the angles, the sum of the angles inside, it's 108. 108 plus 108 plus 108 plus 108, and that's going to leave me with a value of 540 degrees, sum of the angles interior of a pentagon. Now guys, if you do that with all those quadrilaterals, regular polygons, you're going to find the answers as it is in the sketch. Let's go now for a little bit more technical information, calculations concerning the polygons. Now that we do know how to count the vertices, the number of sides, and the interior, physically adding the values as it is given. Let's go more technical information. In this figure, I would like to determine a formula for an irregular polygon. The whole idea, I would like to determine the sum of the interior angle of this irregular four-sided polygon. And therefore the technique I would like to apply, any place inside I would like to put a point, so that I can draw a line from the vertex to that point I have decided upon. There I have construct my triangles. You will find I'm going to have 4 triangles. Number 1, number 2, number 3, and number 4. So let's start writing the formula. Now, I would like to start saying now, sum of interior angles of, and this side or time I would like to say irregular polygons, equals to be, and now my technique I'm going to continue with. I'm going to write 4. Why 4? Because there are 4 triangles. So I'm going to say 4 multiply. Now I do know that if I look at the interior of a triangle, that interior, that angle plus that angle plus that angle of all the triangles individually, going to give me then 180 degrees, the sum of the interior of a triangle. And that's going to leave me then with the answer of 720 degrees. But if I really look at these values now here, I will find that that angle, that part of the triangle, is not on the interior angle of the irregular polygon. So I'm not interested in that angle, as well as that part, as well as that part, as well as that part. But if I start looking now at those angles together, it forms a revolution which going to be equal then to 360. So I have to subtract that from the triangles itself. So I'm going to say minus 360 degrees. And if I'm going to subtract that, now I'm going to end up with a value then of 360 degrees. Now I'm going to look a little bit into more detail in this particular case. Let's just try to separate it down there. I want to go now for the formula. I do understand now that the 720 presents that 4 times 180, and I want to start with that. So in the place of 720, I would like to put the information now 4 multiply 180 degrees. But if we really look at the 4, remember 4 presents the 4 triangles. Now if I go back to the sketch, if I look at this one here, I do see that that side of the triangle also presents that side of the irregular 4 figure. Also similar, that side of the triangle presents that side of the figure. Also this side of the triangle presents that side of the irregular polygon, and then similar thinking, that side of the triangle presents that side of the irregular polygon. Now you will find that the number of triangles will also be there equal to the number of sides. So therefore I'm going to refer to 4 to be the number of sides. And in this case I'm going to refer to the number of sides to the symbol n. But let's first continue with the rest of the calculation. Minus 360 degrees. Therefore, in the place of 4, it refers to the number of sides, n, the symbol, number of sides, multiply 180 degrees minus 360 degrees. Now I have two terms. I'm going to take out 180 as a common factor degrees. I'm going to be left then with n minus, and 180 divided into 360, namely to be 2 times. And here I have derived the formula for irregular polygon sum of interior angles. So let's write it down. Sum of interior angles of, and I would just like to refer to it now as a polygon, equals to, and then I'm going to say, for example, n minus 2 multiply 180 degrees. And guys, I would like you to take this formula down in your exercise books. In grade 8 we do not need to prove the formula, but we must know the formula by heart. Let's go for another idea. If I look at this figures on this page now, I do see that I do have the irregular polygon as well as the regular polygon. Previously we have determined or proved that the interior angles, the sum of the interior angles of a 4-figure irregular polygon, namely to be equal to be 360 degrees. And then we have mentioned the formula in this case then to be sum of interior angles of polygon equal to be n minus 2 multiply 180 degrees. Let's just understand quickly the regular polygon, a quadrilateral. In a quadrilateral, regular polygon, all sides to be the same, meaning that that side, that angle, that angle, that angle, in this case all the angles to be the same. And I also know that in a quadrilateral that 90 degrees, 90 degrees, 90 degrees, 90 degrees altogether going to leave me with a value of 360 degrees. The sum of the interior angle of a regular polygon. So therefore the formula, this formula that we have highlighted then here for a polygon is then for a irregular polygon as well as for a regular polygon in both cases. Very important to know that, because the angles every time interior then to be the same. So the formula for both. But I want to go now to another idea where I'm going to ask, what is the interior angle of, and in this case I would like to refer quadrilateral, in this case of a regular polygon, and I'm just going to say regular polygon, and I mentioned the word regular, equals to. Now guys, because all the angles have to be the same, and there's one thing that we have to see now is that the number of interior angles also presents the same amount of number of sides. 4 sides versus 4 interior, and that's nice to know in all the regular polygons, that the number of sides presents also the number of interior angles. So I'm going to write the value now to be n minus 2 multiply 180, and because the angles are all the same, number of sides, number of terms to be equal, divide by n. And here I have derived the formula now for a interior angle of a regular polygon in this case. Let's just see quickly if we can find the 90 degrees. It's always nice to do a test where I'm going to have number of sides going to be 4 minus the 2 multiply 180, divide that by the number of angles to be 4. Therefore I'm going to have 4 minus 2 going to be 2 multiply 180 degrees, divide that by 4. 2 dividing himself 1, 2 divide into 4 2 times, and I see now 180 divide by 2 going to leave me with a value then of 90 degrees. As we have mentioned before, the interior angle of a regular quadrilateral 4-figure regular polygon is going to be 190 degrees. Right guys, so therefore this formula here, this interior angle only presents regular polygon only. Let's write here only. Guys, please don't mix the formulas. We must know which formula belongs to what polygon. Right, let's go now for a little bit of examples. Example 1. Let's first write it. I do see that I'm sitting here with how many sides? 1, 2, 3, 4, 5. That means it's a 5-figure polygon. But I do see that all the sides is not the same. So what will be the sum of the interior angles be? So I'm going to start writing now sum of interior angles of irregular polygon equals to be, and now the formula for both cases, it's going to be now n minus 2 multiply 180 degrees. So therefore I'm going to substitute, where I'm going to have n presents the number of sides. I've counted 5 sides, minus 2 multiply 180 degrees. Therefore I'm going to have now 5 minus 2 going to leave me a value with 3 multiply 180 degrees. And if I multiply that now, I'm going to end up with an answer of 540 degrees. That means that all the angles together must give me a value of 540 degrees. So I'm going to make the next statement now, where I'm going to say angle A plus angle B plus angle C plus angle D plus angle E must be equal then to a value of 540 degrees. Therefore, if I do some substitution now, I'm going to be left now with 120 degrees plus 112 degrees plus 71 degrees plus 137 degrees plus angle E, which is the symbol S I need to determine, must be then equals to a value of 540 degrees. If I add all those values now, I'm going to end up with a value then of 440 degrees plus S equal to be 540 degrees. Minus 440 on the left, minus 440 on the right, I'm going to have S equals to be 540 degrees minus 440 degrees. So therefore the angle of S must be equivalent then to a value of 100 degrees. Guys, this was example 1. A very nice calculation. Let's try one more example. Example 2. If I'm going to look at this sketch given here, I see that basically speaking it's divided into two parts. I'm going to draw the irregular polygon, highlighting it down there, and I do see that this one having 4 sides. Now by experience I do know that a figure, an irregular polygon with 4 sides, having or equals to a sum of interior angles to be 360 degrees. But let's do it in total. So I'm going to say now sum, and I'm talking to that first part I have highlighted, sum of interior angles of, in this case I'm going to refer to it as an irregular polygon, equals to be, and now my formula I'm going to write down here. I'm going to say now the formula, if we remember the formula correctly, n minus 2, and now multiply 180 degrees. In this case it's an irregular polygon with 4 sides, so n presents the number of sides. 4 minus 2 multiply 180 degrees. 4 minus 2 going to leave me then with 2, multiply the 180 degrees, and then I'm going to have 360 degrees. That is for the first figure. So I'm going to say in that figure, I'm going to say now that angle A plus angle B plus angle C plus angle E must be then equal to a value of 360 degrees. I'm doing a little bit of substitution now. 98 degrees plus 135 for angle B plus The symbol for angle C to be M, I would like to determine. Plus E, 72 degrees equal to be 360 degrees. Therefore, if I add all those values now, I'm going to end up with a value of 305 degrees plus the M equals to be 360 degrees. Therefore, minus 305 on the left, also on the right. So I'm going to have M going to leave me with the answer of 360 minus 305. And therefore, my M value going to be 55 degrees. There I have determined M. Now let's see if we can do the next one a little bit faster. I know now, I'm going to try to put it in here due to space. I know now that the sum of interior angles, and I'm going to look now at this one down here, and I also see that this part of the sketch, I refer now to a triangle, an irregular triangle. Sum of the interior angles, and I'm also going to refer to a irregular polygon equals to be, and the formula once again, n minus 2 multiply 180 degrees. Therefore, I'm going to have then n presents the number of lines, triangle, 3 sides, 3 minus 2 multiply 180 degrees. 3 minus 2 going to leave me with a value of 1 multiply 180. So my total interior, sum of the interior angles of that triangle must be then equal to a value of 180 degrees. Therefore, I'm going to make the next statement by saying now that angle C plus angle D plus angle E must be now equal to be 180 degrees. Substitute C, 39 degrees, plus D, 86 degrees. Angle E presents the symbol N, equal to be 180 degrees. If I add those values now, I'm going to end up with 125 degrees plus the N equals to be 180 degrees. Minus on the left 125, minus on the right 125. So I'm going to end up with N equals to be 180 degrees minus 125 degrees. And that's going to leave me with the answer then of 55 degrees for the symbol N. Guys, you can see once again the formula, how to apply the formula. I'm going to give you a couple of calculations I will really like you to try. And in my next lesson, I'm going to do it then for you. But let's first try a couple of calculations for homework.